Isaac Newton, 1643 to 1727, was an English physicist, mathematician, astronomer, and philosopher who made significant contributions to our understanding of the laws of motion, gravity, and optics. He is widely regarded as one of the most influential scientists in history. Let's explore some key aspects of Isaac Newton's life and work. Newton's most famous work is his formulation of the three laws of motion, which laid the foundation for classical mechanics. First law, law of inertia: an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an external force. Second law, law of acceleration: the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This is expressed by the equation F equals ma, where F represents force, m represents mass, and a represents acceleration. Third law, law of action-reaction: for every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. These laws provide the foundation for understanding the motion of objects, from everyday situations to celestial bodies. Newton also formulated the universal law of gravitation, which describes the force of gravity between two objects. Every particle of matter attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This is expressed by the equation F equals g asterisk m1 asterisk m2 slash r squared, where F represents the force of gravity, g is the gravitational constant, m1 and m2 represent the masses of the objects, and r represents the distance between their centers. This law explains the force that attracts objects towards each other, such as the gravitational pull between the Earth and objects on its surface or the motion of planets around the Sun. Newton conducted extensive research in optics and made significant discoveries in the behavior of light. He conducted experiments with prisms and demonstrated that white light is composed of a spectrum of colors. He also developed the theory of color, which explains how different colors are formed by the interaction of light with objects. Newton's work on optics led to the development of the reflecting telescope, which uses mirrors instead of lenses to gather and focus light. This innovation greatly improved the quality and clarity of astronomical observations. Isaac Newton's contributions to science revolutionized our understanding of motion, gravity, and optics. His laws of motion and the universal law of gravitation provided a framework for understanding the physical world and are still widely used today. Newton's work laid the foundation for classical mechanics and influenced generations of scientists. His discoveries in optics and the development of the reflecting telescope expanded our knowledge of light and greatly advanced the field of astronomy. Isaac Newton's legacy continues to inspire and shape our understanding of the natural world.